Okay, as is frequently the case with these distance equals rate times time problems, it's a good idea to draw a little sketch. So here's town A and town B, 500 miles apart. Here's the blue train leaving at 2 p.m. at 35 miles per hour. And here's the red train leaving at supposedly 3 p.m., but with a 95-minute delay. It's really, well, 3 p.m. plus an hour and 35 minutes later, but traveling at 50 miles per hour. Okay. And hopefully these trains really aren't going to meet. They're going to pass each other at some point in time. And we want to know how long it is before they would have met if they were on the same track. So the distance of the blue train is rate times its time. We're going to let T sub B represent the time of the blue train. So there's an expression for the distance that the blue train travels. The red train is traveling a distance of 50 times the time that it's traveled. And the key is that when the two trains meet, their distances together will add up to 500 because they've covered 500 miles. So there's your basic equation right there. The distance of the blue train plus the distance of the red train equals 500. We'd like to convert that so that there's only one variable. And probably the easiest thing to do is to end up with the time of the blue train. We already have an expression for the distance of the blue train in terms of time of the blue train, 35 T sub B. Now here's the key. The red train leaves 1 hour and 95 minutes after the blue train because this was scheduled at 2, this was scheduled at 3 with a 95-minute delay. So it's an hour and 95 minutes or 155 minutes later than the blue train, or it's traveled that many minutes less by the time they meet. But if we convert 155 minutes to hours, we have to divide by 60 because each hour contains 60 minutes. So that reduces to 31/12ths of an hour. So the time of the red train is 31/12ths of an hour less than the time of the blue train. And so now an expression for the distance the red train travels is 50 times replace T sub R with T sub B minus 31/2. And so here's what we get after the substitution. Now we have one equation with one unknown, time of the blue train. Distribute the 50 T sub B, and you get 35 plus 50 is 85 times the time of the blue train. If you take 50 times negative 31/12ths, that reduces to 25 sixths, which you should see right here. So I added that to both sides, divided by 85. You can do that calculation many different ways, but here's what you end up with. The time that the blue train takes is 7.4 hours. And if you have to find the time at which they meet, convert 0.4 or 4/10ths of an hour to minutes. That's 7 hours. Well, you can't quite see that. 7 hours and 24 minutes. So the time that they arrive is 7 hours and 24 minutes, or 9:24 p.m. Okay, there you go. Hope that helped. If you have any questions, post a comment.